Okay, I'm going to be working through the practice test number 3 for Math 20. This covers everything from 2.7 all the way through 4.4. And we're going to start with problems from 2.7. Your practice test will always go in order of the sections. Your actual test, everything is mixed up, so just know that. But all the problems from the actual test are always taken straight off of the practice test. So if you've done the practice test, you'll be good to go. Okay, the first one is solving for n, and we have a fraction set equal to a fraction. So when we have that case, we're allowed to cross multiply or butterfly multiplication, however you remember it or think about it. So we take the top of the left times the bottom of the right. So that would be 20 times 20 equals, and then we'll have 8 times n. 20 times 20, that's 400, equals 8n, divide by 8, divide by 8, and we find that n is 50. Number 2, the instructions on a bottle of liquid insecticide say use 5 teaspoons of insecticide per gallon of water. If your sprayer has a 7-gallon capacity, how much insecticide should be used to fill the sprayer? This is where we set up our own proportion, where we have 5 teaspoons for 1 gallon equals X amount of teaspoons for 7 gallons, because that's how big our sprayer is. But we set up this proportion, and then you'll see that we have a fraction equal to a fraction. We get to solve it exactly like we did number 1 with cross multiplication. I take 5 times 7, that's 35. I take 1 times x, that's x. So we need 35 teaspoons of insecticide to fill up our sprayer. Number 3, we get to start into our word problems. This one's just translating. It says Mike's age is 1 less than twice Eric's age, which is an A. Write an expression for Mike's age. So Eric's age is the A. That's going to be our variable that we're using. They tell us which one to use. And it says Mike's age is 1 less than. Right there's that special word than, which tells me everything that comes after it is actually going to come first in my equation or in my expression. Twice Eric's age. Twice Eric's age, is 2A. And then we do the 1 less than that would be minus 1. So if we knew what Eric's age was, we could plug it in and we could actually figure out how old Mike is based on this equation, or expression. There's no equal sign in this one, so it's not actually an equation. All right, we're going to find two numbers. It says the larger of two numbers is, right there's a little word is, that's where we put an equal sign. And since we have a larger and a smaller number, I'm going to say the larger number is L, the smaller number is S, just for filling out our equations and being able to solve this. So the larger of two numbers is 7 less than, there's that than again, 4 times the smaller. So we'd have 4 times the smaller minus 7. 7 less than 4 times the smallest, so we put the smaller number times 4 minus 7, that's how big our larger number is. The sum, that means addition, of the two numbers is 83. So that means if I take the two numbers, the larger and the smaller, and I add them together, I'm going to get 83. Now, I've made two equations, but I have two unknowns in each of these equations, so I have to use my substitution method, because I know that the larger number is this 4s minus 7, and if the larger number is the 4s minus 7, I can substitute that or plug it into the other equation in place of my larger number. What this actually does is it produces a single equation with only one variable, our s, or our smaller number. We can solve these. This is straight out of 2.4 when we started solving equations. I'm going to combine my like terms. I have 4s and s. That'll give me a 5s minus 7 equals 83. Add the 7 to both sides, and I'm going to have to start using scratch paper on some of these other problems. I'm going to come over here to the side. We have 5s equals 83 plus 7, that's 90. divide by 5, divide by 5, and I find that my smaller number is 9 divided by 5 is 1, 4 left over is 18. And if my smaller number is 18, since it does ask what are the two numbers, I can put 18 first. It doesn't matter which number you put first. It says use a comma to separate, so I put a comma. But then in order to figure out what my larger number is, I'm going to put it in over here. Because the larger number is 4 times the smaller. Well, if the smaller is 18, I plug that in. And then I'm going to take 4 times 18, which is 72, minus 7. And I get that the larger number is 65. And right here I would do a quick, like, just logic check. Smaller number 18, larger number 65. If I had gotten that the other way around, where it said the smaller number was 65 and the larger number was 18, that doesn't make sense, because 65 is larger, obviously. But also look at the type of numbers we got. We got nice numbers. We should get nice numbers. So if you're not getting nice numbers, then there's probably a problem. We messed up somewhere. All right, I'm going to pull out some scratch paper for some of these other word problems because I don't want to try and cram them in there and run out of space, because these word problems are obviously going to get to be a little bit heftier in terms of what we need to write down. So there we go. All right, let's do the next one. It says a woman purchased a copy machine for $2,100 and a 1-year maintenance protection plan that costs 2 cents per copy made. If she spends a total of $2,478 in a year, which includes the cost of the machine and the copies made, determine the number of copies she made. Okay, so it's a lot of information, but here's the gist of it. The total that the lady spends in a year equals the cost of the machine plus the copies. Okay? Now we know the total. It tells us that. It says she spent $2,478. And we know the machine costs $2,100. And on top of that, we know that the copies cost 2 cents per copy. So that'd be 0.02, but we don't know how many copies she made. That's the problem. So that's our variable. It's 2 cents per copy. So if she made 1 copy that year, it's going to be 2 cents. If she made 100 copies, it would be $2. But now we just made an equation with only one variable. We can solve this. So the first thing we're going to do is we're going to subtract the 2,100 to move it over to the other side. 2,478 minus 2,100 will be 378 equals 0.02 times x. We're going to divide by 0.02, divide by 0.02. So I take 378 divided by 0.02, and I find that she made 18,900 copies in that year. So that's what I'm going to write, 18,900. Again, notice the number we got, 18,900. We didn't get 18,932 copies, 0.7625, something crazy, okay? These should be nice whole numbers, and they shouldn't be too outlandish. Especially if you think, like, if she's making copies, like 18,000 might sound like a lot, but I probably made 18,000 copies this year. All right, let's look at a museum problem. It says, at a museum, adult admission is $11.50, child admission is $8. During one day, a total of 1,800 adult and children admissions were collected, and $18,250 in admissions fees were collected. So how many adult admissions were collected? All right, that's a lot of information, but here's something I know. I'm going to make just some notes. I know adult tickets, I'm just going to call those A's. They cost $11.50. Child tickets cost $8. Okay, so I'm just kind of making notes. One day, they sold a total of 1,800 adult and children admissions. So that means in one day, if I took the number of adult tickets plus the number of child tickets, it's 1,800. On top of that, in that same day where they sold 1,800 tickets, they made $18,250. So what this means is I take the cost of each ticket times the number sold, and that gives me this. This is very much like the rocking chair problem from 3.2, I believe, where, we had the number of rocking chairs sold, and we took it times the cost of each rocking chair to determine the total. This is what we're doing here. So if I take $11.50 times the number of adult tickets plus $8 times the number of child tickets, then I'm going to get the $18,250. Now, here's the problem we come up with. It's very similar to the problem we had up here with our larger, smaller number, in that I have two equations. I had this equation and this equation. I had to do the substitution. Same thing's happening here. I have this equation and this equation, but I need to do a substitution because I can't solve an equation with two variables. So what I'm going to do is I'm going to take this top equation and I'm going to solve it for one of my variables. Since the only thing they're asking me for is my adult admissions, I'm going to solve this one for my child admissions. Because if I do that, so look, I have A plus C equals 1,800. To get C by itself, I'd subtract the A over. So C equals 1,800 minus A, okay? All I did was subtract the A over to the other side. But the reason why I chose to solve for C is because now I know that C is 1,800 minus A. I can take this 1,800 minus A and I can substitute it in here for my C. What this is going to do is it's going to give me an equation where A is the only variable. I'm going to just make that 8 because it's just dot 0, 0. So it's 8 times whatever C was, which is 1,800 minus A, equals 18,250. I know that the only thing they're worried about is how many adult admissions were sold that day. And so by solving for the child tickets here, I have an equation now where only the adult tickets are present. So when I'm done solving this equation, I know how many adult tickets were sold, and I'm going to be done at that point. So what I'm going to do is I have to distribute to get rid of the set of parentheses. So I have 1150A plus, I'm going to take 8 times 1,800. 8 times 1,800 is 1,444, or 14,400, excuse me. I was just saying the numbers as I wrote them, and I was obviously wrong. Then 8 times negative A would be a negative 8A equals 18,250. I have some like terms here, and then I have 1150A minus 8A. That'll give me a 350A plus 14,400 equals 18,250. Subtract the 14,400 over. So I have 350A equals 18,250 minus the 14,400 gives me 3,850. To get A by itself, divide by 350, divide by 350. And I find that there were 1,100 adult tickets sold that day. And again, notice the number. It was a nice number, 1,100. If you're getting fractional numbers when it talks about like the number of copies being made or the number of tickets being sold, then something's wrong because you can't have fractional people or fractional copies and things like that. So these should be nice numbers. I'm about to sneeze. Excuse me. Sorry about that. Be warned, my sneezes usually come in twos, so I suspect another one will come along. All right, let's do our mixture problem. I'm going to rotate my page. There we go. How many pints of 14% isotropic alcohol solution should Jenny Crawford mix with 15 pints of 4% isotropic alcohol solution to get a mixture that is 12% isotropic alcohol? These mixture problems always have so many numbers in them. Like, I know that you can do them without a table. I'm actually going to zoom in a tiny bit more for you guys. While I know tables aren't mandatory, like I can't come up behind you on a test and be like, why aren't you using a table? I highly recommend the tables just because there is so much information that is given in these problems that it's really good to organize. So we're going to have our solution column. And then this one talks about pints. So I'm just going to put number of pints. Then we have our strength. And then we'll have like our amount or total, however you like to label that last one. I don't know how to exactly label that last one. I think amount is usually what they label. So the first type of solution we have is a 14% solution. Then we have a 4% solution. And then we're going to have our mixture. Those are the three kinds that we're going to have. I know the strengths of all of these because they give them to me, and honestly the strengths is typically how we note what kind of solution is. Just remember that when you're dealing with your strengths column, you have to convert your percentages into decimals, which means you take your decimal place to the left 2 points. So 14% would become 0.14. 4%, if we take it 2 places to the left, notice we'll have a gap, so that'll be a 0.04, and it says our mixture is supposed to be 12%. So that'll be 0.12. Looking through the problem, the only other number I don't have right now is that Jenny is going to mix with 15 pints of the 4%. So I know I have 15 pints of the 4%. And that's all I know. There's nothing else in the problem. So what I need to come up with is it's asking me how many pints of the 14. That's my X. That's my unknown. So I put that there. Now you're like, okay, but we don't know how many pints of our mixture we're going to have. But we do actually, because we know we're going to have X amount of our 14. We're going to have 15 pints of our 4%, which gives us how much here? If you're not sure, think about it like this. What if I said we had 1 pint of our 14%? If this was 1 and this is 15, how much total would we have? We'd have 16, right? Because what we did is we took the 1 plus 15 to get our mixture. We do the same thing here even with the variable. We take the X plus the 15. That's going to tell us how much of the mixture we're going to have. So here's kind of the trick of all the tables. You always add down your columns, but you're going to multiply across your rows. So to get our amounts category over here, which is going to be the equation we're going to play with, we're going to multiply across all of our rows. And in general, I don't generally actually do the multiplication here. So like I'll just say 0.04 times 15. If you want to go ahead and figure out what 0.04 times 15 is and put that in there, that's totally up to you. I just leave it. And I do that when I actually write it out as a full equation down here. Because remember, if you take the time to do your table, your equation is going to be this last column. We have the amount of our 14 plus the amount of our 4 will give us the amount of our mixture. So that's what I'm going to write. I'm going to have 0.14x plus 0.04 times 15 equals 0.12 times x plus 15. Now I'm ready to solve this because this equation, even though it's got variables on both sides, it's only got one variable. I can do this. I have 0.14x plus, and I will go ahead at this point and take the 0.4 times the 15 to get me 0.6 equals, and then over here to get rid of the parentheses, I have to distribute. Distribute the 0.12 times x to give me 0.12x, and take the 0.12 times 15, which gives me 1.8. Now, I have x's on both sides. I can pick to move my x either direction, but I generally will move it in the way where I have more. So I have 14 over here on the left. I have 12 over here on the right. So I'm going to choose to subtract the 0.12x and move it over just so I can keep my variables positive. 0.14 minus 0.12 is 0.02x plus 0.6 equals 1.8. Still trying to get x by itself. I'm going to subtract the 0.6, subtract the 0, that's a wonky 0, but there we go, 0.6. And I get 0.02x equals 1.8 minus 0.6 is going to be 1.2. Divide by 0.02, divide by 0.02. Oops, sorry, I ran off. So I take 1.2 divided by 0.02, and I find out x is 60. I need 60 pints of 14% solution to be added to 15 pints of the 4% solution in order to get a 12% isotropic alcohol solution. So 60 is going to be what I write, or what I would type in for that problem. So there's a lot of information in the mixture problem. The table is honestly a great way to organize it. If you're not going to use the table, the way these problems end up working is you take the strength times the amount that you're going to have of that product. So the strength times the number of pints. Strength times the number of pints equals strength times the number of pints of your mixture. Like you'll have your first solution, second solution, you add those together to get your mixture. That's the way the equation actually works. But as I've mentioned, there's just a lot of numbers, and so the table is really nice in organizing it. All right, let's see what the next one is. It's a graph problem. Luckily, they give me the graph. It says graph the equation y equals 1. All right, so this one doesn't have an x in it. It just says y equals 1. So when x is 0, y is 1. When x is 4, y is 1. When x is -8, y is 1. This is our horizontal line. So when you graph it on Pearson, you only need 2 points, and they just all need to have a y value of 1. It doesn't matter what x values you choose. So don't make it harder than it needs to be. That's all we're doing. All right. Number 9 says graph by plotting points. Now, we have gone through all of chapter 4 at this point. When we hadn't, and we were in 4.2 the first time, we made like a little table, and we picked some x values, and we did it that way. Now that I know what y equals mx plus b is, I'm going to use those as my points. Remember, y equals mx plus b, this is our slope-intercept form. The m is our slope, and the b is our y-intercept. So I'm going to identify both of those components, and I'm going to graph using those. So looking at this equation of y equals 5x minus 1, my m, my slope, is 5, and my b, or y-intercept, I'm going to write as an ordered pair. Those always look like 0, comma b. My b in this case is -1. So I'm going to start by plotting the point 0, -1, which is over here, and then I'm going to use my slope to plot another point. Now, my slope is a positive 5. I'm going to make it into a fraction so I can visualize the vertical change, the rise, the top number, over the horizontal change, the run, my bottom number. So the top number is your vertical change. That's what the change is at vertically as you rise. And if it's a positive 5, positive vertical movement means you're going to go up. The bottom number is your horizontal change. Horizontally, if it's positive, that's going to take you to the right. So from that y-intercept of 0, -1, I'm going to move up 5 and to the right 1, and I'm going to plot that second point. So I start at my y-intercept, and I go up 1, 2, 3, 4, 5, and to the right 1, and then that's where I drop my second point. And then on Pearson, I would just be drawing a line, but here I have to actually like have a little bit of a ruler situation. And there's our line. All right, let's keep going. Using the slope formula, find the slope through the given points. So remember, our slope formula, m equals y2 minus y1 over x2 minus x1. That's where we have two ordered pairs, and we plug in the values. So what I always do is if they give me two ordered pairs, I just leave them in the order they're in, and I label them x1, y1, x2, y2, and then it becomes a plug and chug situation. I don't even have to think about it. So it helps me to do this, so that way I don't accidentally say, okay, x1 is 12 and y1 is -5, because that's not true, and I just made a new ordered pair. So I always write the formula, and then I often will label, so then I don't even have to do much thinking. So if m equals y2 minus y1, my y2 as I have it labeled is a negative 5, minus my y1 is 0, all over x2 is 2, minus my x1 is 12. So now I just need to simplify. On top, negative 5 minus 0 is a negative 5. On bottom, I have 2 minus 12 will give me a negative 10. Negative over negative cancels because a negative divided by a negative is a positive number. And then 5 over 10 can simplify to 1/2. So my slope is a positive 1/2. You will type that as a fraction. You will not give a decimal representation, ever. So don't do that. All right, so this one is kind of where they give us a graph and we get to figure out the slope. Now, there's a couple ways you can approach this because they even label 2 dots for you, like 2 points on the graph. So you very much could just identify those 2 ordered pairs and you could do the formula. That's probably the safest way, where we do exactly what we just did. Like we label this point 1 and this point 2 and we find out that ordered pair, which is a negative 1, positive 2, negative 1, positive 2, and this one down here is over 2, so that'd be 2, comma, and then down negative 3. So right there I've identified the 2 points that they gave me on my picture, and I could do the x1, y1, x2, y2, and I could plug it in. The other way you can do it is you can just identify your vertical change between these 2 points, and then your horizontal change. So vertical change, if I go from the bottom point to the top point, would be 1, 2, 3, 4, 5. To go from the bottom point to the top point, I have to go up 5. So that's my vertical change. Remember, vertical over horizontal. Now, to get over from my bottom point to my top point, I have to go to the left, 1, 2, 3. Left, horizontally, is a negative direction. That means my slope had better be a negative 5/3. I'm going to write it over here, but then honestly, I'm going to go ahead and do the actual formula just to check it. But a visual check here, remember we have positive and negatively sloping lines. As I read this graph from left to right, it falls, it goes down. So this is a negatively sloping line, so I do have to end up with a negative slope. At least that checks out. Now I'm going to do this computation over here just to make sure the numbers actually match. So again, I'm going to do x1, y1, x2, y2, and I'm going to say slope is y2 minus y1 over x2 minus x1. And you're like, why do you write the formula down every time? The more you write it down, the quicker you will memorize it. So that's why. All right, y2 as I have them labeled would be negative 3 minus my y1, which is a positive 2, all over x2, which is 2, minus x1. Now, the minus is part of the formula, but my x1 is already negative, so I'm going to have a minus minus. A minus minus produces a positive. Negative 3 minus 2 is a negative 5. 2 plus 1 is 3. So look, I do get a negative 5 over 3. And some of you might be like, well, wait a second. Over here, the negative is on the bottom. True, but remember, we can never have or leave a negative in our denominator. It always goes up top or it comes out to the side. You never leave it in the denominator. So either way, we got the exact same thing. So you can find the ordered pairs that they give you and actually do the computation, or you can visually count, but just make sure you understand that if you move to the left, it's negative, or if you move down, it's negative. If you move up, it's positive. If you move to the right, it's positive. So you have to be careful there. I'd say identifying the ordered pairs and plugging and chugging is the safest route. All right, let's look here. It says M1 represents the slope of line 1, and 2 represents the slope of a distinct line, line 2. That word distinct is telling you it's a separate line. It's telling you that it's a unique line. Indicate whether line 1 and line 2 are parallel, perpendicular, or neither. So remember the rules for parallel, perpendicular, or neither. Parallel lines, same slope. Perpendicular lines, negative reciprocal slope. And if you're neither of those, then you're neither. That just means you're crossing somewhere else. So I need to look at my two slopes. I have M1 is negative 3/2, M2 is negative 2/3. So the first thing I note, they're not the same number. Okay, so they're not going to be parallel automatically. So then I check to see if they are perpendicular. In order to be perpendicular, the signs have to be opposites, because that's what negative means. You'll have one slope that's positive, one slope that's negative, and then they have to be the flip of each other. So if I look at this, they are flips of each other, because I have 3/2 and 2/3. However, both of them are negative. If they're both negative, they cannot be perpendicular. So this is going to be a neither situation. All right, number 13. Determine the slope and y-intercept of the line given in the equation 2x minus 3y equals 21. So this is our standard form. In order to find our slope and our intercept, we need slope-intercept form, y equals mx plus b. So I need to get this equation into that format. So I have 2x minus 3y equals 21. So basically what I'm trying to do is get y by itself. That's what I need to do. So I'm going to subtract the 2x over, because my goal is this y equals mx plus b. That'll leave me with a negative 3y equals. And then over here, generally, I would write 21 minus 2x. But I know my x term has to come first. So I'm going to go ahead and write minus 2x plus 21, because at the end, I need that x term first. To get y completely by itself, I'm going to divide by negative 3. And because I need to have mx plus b and have these as individual terms, I'm going to do individual divides, like this. That will get y by itself. Negative divided by negative produces a positive, so I have a positive 2/3 x. Positive divided by a negative is a negative, so that produces a negative. 21 divided by 3, 7. So this is my y equals mx plus b format. Now, it says, what is the slope? Well, the slope, if I have it written in this format, is the coefficient of my x, because that's my m. So my slope is 2/3. The y-intercept, excuse me, look, type an ordered pair. If you do not have parentheses around your ordered pair, it's not an ordered pair. Excuse me. So I have to have parentheses. My y-intercept means I always have a 0 in my x, and then I look at whatever my b is. My b in this case is a negative 7. Whatever the sign is goes with it. So it'll be 0, negative 7 inside of those parentheses. That is my y-intercept. Okie dokie. 14. Determine whether the pair of lines are parallel, perpendicular, or neither. Okay, we already made the notes up here. Parallel lines have the same slope. Perpendicular lines are negative reciprocal slope. The problem is that we don't know what the slopes of these lines are, because they don't tell us, and they're not written in y equals mx plus b format. So that's what I need to do. I need to write each of these equations in y equals mx plus b format, because that's going to tell me the slope, and then I'll be able to examine those. So I'm going to do the first one. Let's see, how high up can I go? Right there. 4x plus 2y equals 9. I need to write this in y equals mx plus b format. So I'm doing the exact same thing I did on the problem above and manipulating my equation around. I'm going to subtract the 4x to both sides, and I get 2y equals negative 4x plus 9. Divide by 2. Divide by 2, divide by 2, and I get y equals negative 2x plus 9/2. So my slope for that first equation is negative 2, because that's the number in front of my x. Then I go and do it again. I have 4x equals 8y plus 12. That's the second equation. I need to get it in y equals mx plus b format. It's written with the y on the right hand side. That's okay. You can have mx plus b equals y. Totally okay. So I'm going to subtract the 12 to move it over because I need everything away from my y. I get 4x minus 12 equals 8y. Divide by 8, divide by 8, divide by 8. 4 divided by 8, that's 1/2 x. 12 divided by 8, that's what, 3/2 equals y. The only part that I really care about is the number here in front of my x. The slope of the second line is 1/2. So notice the slopes are not the same. So I know it's not parallel. I have a negative slope and a positive slope. So then the question is, can I flip them to get to the other one? So can I flip 1/2 over? And if I do that, it becomes 2 over 1. If I change the sign, then it becomes negative 2 over 1, which is a negative 2. That tells me that these lines are perpendicular. Two more problems. Look at that. This one's exactly the same. Exactly the same. Determine whether the given pair of lines are parallel, perpendicular, or neither. So 3x plus 5y equals 9. Getting y by itself, 5y equals a negative 3x plus 9. Divide everything by 5. And I get y equals a negative 3/5 x plus 9/5. So that means that the slope for that top line is a negative 3/5. Now let's do the exact same thing for this bottom one. We have 6x equals a negative 10y plus 9. Trying to get y by itself, I'm going to subtract the 9, subtract the 9. 6x minus 9 equals a negative 10y. Divide by negative 10, divide by negative 10, divide by negative 10. So 6 divided by 10, those each have a factor of 2, so that'll be 3 over 5, and it's negative. X plus, because we have negative divided by negative, 9/10 equals y. Slope of this one is negative 3/5. So I have slope of negative 3/5, I have slope of negative 3/5. If the slopes are the same, they're parallel lines. One final problem. Write the equation of a line with the given properties in slope-intercept form. If you're ever asked for the equation of a line, they want y equals mx plus b. Now the problem is we're given just 2 points. We're not given anything else. So the first thing we have to do is we have to find our slope. Slope is y2 minus y1 over x2 minus x1. I'm just going to label them in the order they're given. x1, y1, x2, y2, like this. And then I'm going to plug it in. y2, as I have it labeled, is right here, it's 9. Minus my y1. My y1 is a negative 7, so a minus minus becomes a plus. I'm being careful. x2, as I have it labeled, is a negative 7 minus x1, which is a negative 9, so negative negative becomes positive. 9 plus 7 is 16. Negative 7 plus 9 is a positive 2, which means I have a slope of positive 8. Now, I have slope and 2 points. I have a special formula that has slope in 1 point. That's my point slope form. Y minus y1 equals m times x minus x1. So what you can do is now you have slope in 2 points. You can use the slope you just found and either one of the 2 original points. It does not matter which one. It will work out to the exact same equation regardless. I'm going to go ahead and just go with the first point because I already have it labeled x1, y1, and we're just going to go with that. So y minus my y1 is negative 7, so a minus minus becomes a positive. My slope was 8. x minus my x1, again, minus minus becomes a positive. Now I'm going to distribute that 8 to get rid of the parentheses. So I have y plus 7 equals 8 times x is 8x. 8 times 9 is 72. Subtract the 7, subtract the 7, and I get y equals 8x plus 65. That is the equation of the line through these 2 points. So it'd be y equals 8x plus 65. Notice I didn't stop as soon as I plugged in to this point slope form, because that's not the equation of a line. You're not done until you look like y equals mx plus b. That is the way they want all of your equations if they're asking for a linear equation.